Okay, U minus UT, right? Minus UT is here, right? You flip with respect to vertical or horizontal? Horizontal, right? You get it. Okay. Next one, you shift. Okay. Shift by A. In left hand or right hand? Right hand. Okay. By A. Maybe here. Any point in here, right? If this point is there. Okay. 0 and in this case, you separate them in 3 pieces. Right? Use this point, 0 and 0 give you 0, right? Yeah? 1 and 1, 1 add with 1 give you. Oh, sorry. This, sorry. 1 add with 0 give you 1. 1 add with 0 give you 1, right? And 1 and minus 1 give you 0. 1 and minus 1 give you 0. Okay? The result is about the blue cloud, right? Yeah. What about that? Where you get from? This is match to your answer or not? Okay. After you do them by yourself, I think you get more understanding more. The next step, okay, the question is not ask you to skip this scaffolding. It's ask the first derivative. Okay, the first derivative, you know that if you differentiate ut, give you the power from the definition, right? From the definition, the in power at 0. At 0. Yeah, at 0. Yeah. Yeah. Therefore, this here. Okay. You get the derivative at 0. Right? At 0. The delta function at 0. Okay. For here, if you shift things unit step by A, the in power will be axis at further derivative, okay, the in power will get at A instead, right? The unit step shift in the right hand by A, the in power will be shift in the same manner. Okay? Okay? By A. Right? But what are these transform? Amplitude reversal, right? If you reverse in here, the power will be reversal, right? Yeah, therefore it will be given here. Now you know where it came from. Why? Okay? Read them step by step. Next one is here. Determine and get the following signal and its derivatives, okay? Okay, for this case, the signal is a little bit complicated, okay? T is minus for this case, right? Okay? T minus for this case, okay? You may be distributed first, okay? Right? How many terms we have? How many terms we have in this here? 2 terms, right? We split them in 2 terms, okay? The first term is the same, okay? The first term is scared, okay? UT is here, right? UT, okay? T is here. Therefore, the result will be, for time greater than 0 is equal to 0 multiply anything give you 0, right? For time greater than 0, 1 multiply anything give you that thing, right? That thing. Okay? This is belong to the first class. Okay? The first class. Okay? But this, okay, okay? In this case, you can see that you cannot use, okay? You cannot plot T, UT, and you cannot shifting them. No. Why? Because in this case, it's only UT that shift, T is not shift. Okay? Right? In the previous assignment, you used to see here, right? T minus 1, U, T minus 1, right? For this class, okay, I teach you to plot them TUT, right? And you will shift them, shift every T in the right hand side. Therefore, the result is here, right? But here, cannot use. Why? because in this case, for T, it has no shifting, right? It has no shifting. Don't worry about it. If it has no shifting, how to compute it? You get each term separately and multiply it. Okay? T, ut minus a, ut for ut, for time less than 0 is equal to, for time less than 0 is equal to, yeah, for time less than 0 is equal to 0, time greater than 0 is equal to 1, right? You shift by a, seem to be multiplied here, right? Shift by a in the left hand or right hand? Right hand, okay, get here. Right. Next one, for T cloud is here, right? T cloud is here. Minus T, what about minus T? Flip right, respect to vertical or horizontal? Yeah, horizontal, you get here. Right? Flip it. Okay, now, 0 multiply anything give you 0, okay, until here, right? 0 on. Okay? 1 multiply anything give you that thing, right? That thing. Okay? You add between two graphs. Okay? We have two ways to add in there. Don't worry about it. I will teach you both. Okay? Yeah? You add between this graph and this graph. Okay? Cut them in this piece. Okay? We can plot them in the same manner. Okay? Okay? Now, cut them. Okay, we add between the blue graph and the red graph. Okay? I erase about the white one. Okay? The white one. Okay? Okay? We cut them in. In this case, you can see that, okay? It's 3 pieces, right? 3 pieces. Each piece of them. Okay? Yeah? For this, okay? The red equal to 0. The red equal to 0, right? The blue equal to 0. Okay? The blue equal to 0. You adding them, give you 0 and 0 give you 0. 0 and 0 give you 0. Clear? Now, it's here. Okay? The red equal to 0. Red equal to 0 again, right? Okay? The blue equal to 0. This point, the slope there equal to 1, right? And this point, okay? This point is located at A, right? Okay, therefore, this will be A, right? Okay? Therefore, the blue one at this point equal to A. Right? The straight line, slope equal to 1. Okay? Now, okay. 0 and 0 give you 0 and A give you A, right? Give you A.เดี๋ยวใช่อันนี้ต้องลงมาตรงนี้โทษทีอีกนิดนึงใช่ไหมเดี๋ยวเราต้องสตาร์ทตรงนี้ใช่ไหมโทษที นี้ใช่ไหมเพราะตัวนี้มันเป็น UT ใช่ไหมอ๋อเหมือน T UT minus A ใช่ไหมใช่ไหม sorry when you multiply that okay 0 multiply anything give you 0 I give you this a little bit wrong in this point okay 1 multiply anything give you that thing right give you here okay therefore the star is here sorry okay now this point and this point equal to A both right equal to A okay okay the red in this point equal to minus A right and this point the blue one equal to A you add them give you 0 right and the slope and the value will be reversed therefore the effect of them will be 0 okay therefore the result of the green is okay in the final ring keep you here and here okay okay the two I get in the black box okay it may be something mixed okay you can remind me okay don't worry about it now you see that the result is here this is the first computation okay the second one you can compute by it means unit step and subtract unit step first okay can you erase that okay 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 you can sketch unit step and unit step from the previous right give you here right this UT from the previous exercise right the second one okay T right now 0 multiply anything give you 0 right 1 multiply anything give you that thing right that thing okay therefore it give you here right and 0 multiply anything give you 0 again okay therefore this is the same result okay you can multiply them first or you can test okay erase that okay now okay and the derivative of them will be here okay okay the derivative of the unit step give you the e power unit step okay the derivative of the unit step that you shift by A give you the e power that you shift by A too okay and in this case if you verify the derivative of the T multiply with this okay you can multiply them give you here okay multiply T here once okay give you this is for the overall impulse computation wait a minute okay I will show you here okay this step the first one is here okay okay you can see that in this point okay the derivative of them is here take the derivative of T UT take the derivative of T give you 1 right okay give you 1 okay UT is still the same okay not affect by that okay and in the derivative next one you take the derivative of the second term okay when you see here what about that okay the way to take derivatives okay I will remind your formula okay you take the derivative of ft do you remember right you can see that T and UT is a variable of T right you can see them to be F and G okay when you take the derivative of them you take the derivative F take the derivative of G plus F plus G clear that's why it's split in two terms okay this term you don't do it right it perform like right F okay and take the derivative only G okay and the derivative clear where it came from calculus 1 anyone forgot that Okay, right? When I remind show you here, you already know. Okay, and when you take the derivative of the unit step, okay, it will give you impulse. Okay. The difficulty of the unit step and the impulse is when you take the derivative of unit step, you cannot use derivative of the by the normal function. Okay. Unit step give you one. Okay. Is here. Therefore, it is scale. For the models, when you plot them, ut and ut minus a, right? Give you rectangle. Okay, and this term is here, right? Is here. Okay, and this. Okay. Now the next one. Okay, we will go fast. Okay, the mathematical functions for. Yeah. Already teach you, right? How to write the mathematics, okay? To be the cloud, okay? How to add them in each step, right? And how to write the cloud to be the mathematics, okay? Yeah, it's already exercise, right? That they give it to you, okay? In this case, how many terms we have? You can split them into 4 terms. 4 terms, yeah? Okay, what about 3 is represent for amplitude? Amplitude plus 3 represent for time shifting. Shift in left hand or right hand? Left hand, right? Unit step at the center, right? You shift in the left hand by 3. Yeah, units, okay, and you amplify 3. Yeah, yeah. The green one correspond to, yeah, that's one. The next one, minus ut. Minus ut, what about this? Minus represent for amplitude reversal. Yeah, amplitude reversal, right? Yeah, that's fine. Yeah, and next one, plus 3 represent for amplitude scaling. Okay, minus 3 represent for time shifting. Left hand or right hand? Right hand by 3. Okay. This case, okay, you take amplitude first. Okay. Yeah. Last one. Okay. Minus 5 represent for minus represent for amplitude reversal. 5 represent for amplitude scaling. Plus 6, minus 6 represent for time shifting. Shift in the left hand or right hand? Right hand by 6. Okay. Okay, and the unit step that go down, right? Reverse. Okay. Here you add each page. Okay, the way to add, I can go fast. Okay. I think everyone know how to add them. It's not necessary to show you in the detail. Okay, we cut them in each piece. Okay. Okay. 1, 2, 3, 4, 5. Okay. 5 pieces. Okay. You plot each piece of them here. You won't that okay, the thing that you add is matching to your understanding. Matching to your answer or not? Now, the difficult of this question or in the engineering subject is here. The scale. You have the function and you scale it only the beginning, right? The beginning step. But here, transform. If you scale them long, even though you transform them right, your final answer is still wrong, right? Now, in this case, minus represent for time reversal. 3 represent for time scaling, and minus 6 represent for time shifting. Which step we take first? Shift first, or reverse first, or scale first? Shift first. In this case, you shift, okay? T naught equal to 6. Shift in left hand or right hand? Right hand by 6. Okay, now. Okay. Okay. Okay, to show you in the animations we give you, we require more crest line. Okay, shift in. Okay, right hand by, okay, the original signal, right? And you shift in the right hand by 6, right? Shift them by 6. Okay, clear? Shift them by 6. Okay. What about next step? Next step we take. Okay. Scaling, okay? Scaling is scale. You scale by 3. You might compress it. Okay, compress by 3 part. Okay. It used to be 3. Okay, you move them to 1. Okay. Yeah. Yeah. Finish. The last step you take. Reversal. Flip respect to vertical or horizontal? Vertical, right? Vertical axis. Clear? I think if you do by yourself, you're only checking that the thing that you understand is right or wrong. Okay? When you see in the slide, it's already firm, confirm your idea. Okay? But if you don't do anything, you see the slide, you see it's smooth and very easy. Okay? But when you really do it, it's not smooth right there, right? Whenever you do, it should be free. It should be free. How is free? It's easy. That I told you it's free, right? But when you flip them, okay, sometimes it's not identical or something like that. Okay, now. Conนี้ทำยังให้ทำป่ะ Yeah, okay, not yet. Okay, don't worry about that. Okay, I will give you next time. Don't worry about them. Okay.วันนี้ให้ทำน้อยหน่อยเดี๋ยววันนี้ต้องจบเรื่องนี้นะเดี๋ยวไม่จบเดี๋ยวไม่ทันสอนไม่ทัน You see that okay in this chapter how many sections we have 7 right the first 5 sections is only the signal right you treat you have now you have the ability to treat the signal in the several manner right Amplitude transform, time transform, okay, even part, odd part, adding them, okay, so many things, right? Sketch them, how to sketch in the map or how to write the cloud to be the map function, okay? Now, what about the subject title? The subject is the signal and system. Now, we will concentrate on system, okay? And the system that we concentrate in here is only analog system first, okay? Analog system from the mathematics analysis, we call them continuous time. Yeah? The continuous time system. Yeah? What about the system in the engineering point of view? Okay? The system is a process for which cause and the effects relation exists. Okay? The cause is the input. Okay? The cause of the is the input that you feed there, okay? The relation between the input and the output is the mathematically expressed is modeled by equation. Yeah, the linear equation or the differential equation that you study in the calculus 1 and 2 and in the math we use in here, okay? We study the mathematics, okay? Not because we love them, okay? We study them because we try to use them as the tool, yeah? To model the amplifier, to model the motor, to model the transformer. Before you have the ability to model them, okay, you must know about the mathematics first, okay? You will know this equation suitable for this equipment, this system. Now, okay, and in general, the system can be represented by the block diagram as the following here, okay? You see that the system that I show you in the first, okay, first chapter, okay, maybe operational amplifier, op amp, maybe the resistor, maybe so many equipment. We don't care, right? The thing that we see them to be a black box. Okay? The system is maybe have 1 input, 2 input, 3 input, okay, so on. Okay? In this case, for the simple analysis, okay, we have only 1 input. Okay? Output is equal to the transfer function of the input is. If the system is very simple, such as the microphone. The microphone is only, okay, the input is the voice, right? My voice, okay? You only amplify them. Okay, amplify them by 10 times or 5 times. Very easy. Yeah. Or some system is a little bit more complicated. For example, okay, about the delay, about the operational amplifier that you have, about the integrator or differentiator operator. Okay. You instead output equal to input directly, no, you must integrate them or you must differentiate them. Okay. That you must learn in the next subject after this. Okay. When you study about the control subject, the control, okay, the control will model a huge complex system in the factory by 3 block diagram. The first one is multiply them directly. We call them proportional. Okay. Y equal to maybe constant x, something like that. Or we use the P or proportional. Okay, you can see that y depends on x directly. Okay, P is only constant. If P equal to 5, y equal to 5x, something like that. Very simple. Okay. The second is came from the mathematics. Okay, the second, okay, y may be equal to differentiate of x. Differentiate of x. Okay, we call them D, differentiation. Or y may be equal to integrate of x of the input is. We call them I. Okay, P, I, D, proportional, integrator, and differentiator. You can see that we use 3 blocks that based on the mathematics that you study. Proportional, differentiator, integrator. Okay, compile them into the big factory, and we can model them for the real factories. Okay. Now, for example, to make you more understand about the system, okay? Okay. Okay. This system is a little bit more complicated, right? This resistor, right? This inductor, right? Okay, it's an RL circuit. Okay, you have the solid here. In this case, if the input is the voltage that you feed into the system, okay, and the output equal to the voltage that you measure from the inductor. Yeah, you can see that, okay, from this, okay, you can apply K, CL, KVM, KVM, clockwise or counterclockwise, y direction, okay, plus or minus, minus V, right? Here, plus by I, right? Plus I, or VI, right? Plus or minus, plus VL, okay, VL, okay, you can express them in the term of I after. Okay, VL equal to L DIDT. Okay, DIDT, right? Now you can see that in this case you can use the differential equations. Okay, the first step you apply the physics law, right? The Causality law is one of the physics law. After that you substitute them. Okay, you reorganize them. Now you already get the differential equation. The way to solve the differential equation is belong to the physics or belong to the mathematics subject. Mathematics, right? The mathematics subject that you study. Okay? The first time you formulate is belong to physics, right? Physics law. Okay? Therefore, in the engineering job, we separate the job. One, apply the physics law to model the system. Okay? Maybe apply Kirchhoff law, voltage law, okay, Ohm's law, maybe the Newton law, thermodynamic law, Maxwell equation law, we don't care. Okay? And after that, after you get here, it's made. If in the linear equation or the differential equation, do you afraid of that? No. The form is, in fact, is so easy when you compare for the final exam in EE, right? The final exam in EE may be the second order or the third order. Yeah, but here it's only the first order, right? In this case, you may be seeing that it's a little bit complicated, but no. In the real case, L and I is only constant. Maybe substitute by 10 or 5 or something like that. Yeah. Now we have, okay, the thing that you would like to get the output from the system, which we have equal to L DIDT. Okay. In the engineering, okay, this is for the real physics system. In the engineering, okay, we see that to be here. You feed inputs, okay? The input is the voltage, right? Okay. Output equal to we have, right? Relationship between input and output, you explain them by differential equation. Yeah. Okay, this is block diagram. Okay. Next one. In the previous example is already show you a simple one, right? We have one input, okay, such as the voltage, okay. We have one output, okay, maybe we have, okay, very easy. In the real case, you maybe have 2 or 3 input, okay, 2 or 3 input, okay. And each input may be added here, okay, you maybe only adding. Output equal to the adding, okay. The summing instruction we use adding here, okay. Or if you have A and B, I want X1 and X2 and it multiply, give you here. This is a symbol that we schedule. Because if we have the complex system, okay, we try to, instead we write in the detail or no, we separate them in 2 or 3 main blocks first, okay, and sketch how to connect it with them. We analyze each block, okay, and sketch them in the detail later, you may have the questions why you must split like that, because in the real designing, okay, if a small block is already correct one, okay, for example, you have, okay, you build all, no, you build each block first, right? For example, when you create the robot, okay, you create all robot, no, you maybe only maybe the leg first, okay, analyze the legs, okay, how many hydraulic it have, how many wheel it have, okay. After you fit them, it's already firm, okay. If the first block is firm, it's correct one, okay, you keep it, right? You create the second block, third block until you do the last one, right? If the second block is not work, okay, you cannot complain it came from the first block, right? Because the first block you already tested already, you create, okay, you know that the problem should be came from the second block that you built, until you can fix them. After you fix them, you connect them, right? Checking that, okay, the interconnection is okay or not, okay, or it have some sort of voltage lead or the current lead or the two friction, then your assumption is like that. For example, sometimes when you add 2 blocks together, sometimes you cannot, the robot cannot work like you decide because you maybe think that hey, the current that it generates from the second block may be lower than you expect. Therefore you must tune it. For the parallel is instead you have one, okay, two systems, two system parallelity, and add the result. You may have the question, okay, in the real design, why we don't create a single block system, okay, why we create 2 parallel systems, okay, it maybe came from the budget point of view. For example, if you buy one big hydraulic, it may be 1,000. If you instead use a single hydraulic node, you maybe use 2 smaller hydraulic. Each of them may be 200 instead. You see that? 2 hydraulic is only 400 baht, right? It's cheaper. Audio from, in the military point of view, it came from the reliability. For example, anyone used to see about the battle airplane, right? The battle airplane, the jet. The jet in the fight. For example, it usually, F-18, something like that. You can see that how many jets it have? 2 jets, right? Why? Because if one is broken, another one can bring you to the airport. If you have a single jet, such as F-16, if it's broken, nothing left. For example, it used in the commercial point of view too. For example, when you take the flight to your home, usually you have 2 or 4 jets, right? Depending on the distance. If you go to the US, you usually use the bigs, you maybe have 4 jets. If one of them is broken, another 3 can maintain the ship, not sink. Even though it's not run at the full speed, but at least it's not crash. In the real military, one of the oldest bombers airplane start using the second, maybe the Vietnam War, Second World War, maybe 50 years, it's still using. Do you know why? It's very simple. It has up to a small X engine. If you would like to crash them, you must destroy at least 3 or 4 engines. If you are the fighter, you must fly several times, right, to hit 3 or 4 engines. Okay? If maybe 4 or 5 engines still exist, okay, still working, this bomber is still working. Okay, for example. Is that the plan? Okay, the US military is already have the plan to rebuild it, upgrade it. Okay, but use the same model. Maybe upgrade the engine to have the more powerful, upgrade the armor with the better material. Okay, redesign them to have the better dynamics point of view or something like that. But everything is still the same. Okay. Now, okay, that's what you might have to. Okay. Sometimes, if you have 2 hydraulic of the robot, okay, even though not only is cheaper, if one hydraulic is broken, at least your robot can walk, maybe not full function. But if you use a single hydraulic and the hydraulic is stopped, your robot cannot walk anymore, right? This came from the reliability point of view. Yeah. In the overall point of view, even though the size drop is have 2, but the out. Okay, in the overall, you see that we have X, okay, and we have Y. Okay, only that the overall system, we don't care how many inside block it is. We say there to be a single block, okay, a single process. Now, okay, a series and a parallel connection is here. For the series is here. Okay, the series is when we really decide, for example, about the controller's point of view, okay, the signal from the controller that generates from the controller, it is possible to drive the motor directly. No, because the microcontroller will be generated only a microamp, right? It's required to pass about the amplifier first. Okay, maybe op amp to expand or to increase the voltage level or the current level. Okay, before you drive the motor or drive the robotic state. Yes, I can see. Yeah, but in the overall point of view, you see them to be a single process, right? Amplify them first and process them later. Yeah. Yeah. Now, in the overall, in the real factory, okay, you maybe have so many blocks, okay, so many sub process. In this case, how many sub process we have? 1, 2, 3, 4 sub process. Okay, you must extract or write the output in the term of the input. Okay, even though in this case you cannot get them in the closed form because T1 and T2 is not clearly in differentiation, proportional, or the integration yet. Okay, we write them at the abstract first. Okay, in the next subjects, okay, we will teach you how to write them in the single closed form equation. Okay, after you do that. Okay, y3 equal to y1 plus y2, right? y1 equal to x1 and process of the T1, right? x1, x and process. y2 is T2 of x, right? The process. Okay? Yeah. Now, you see here, output equal to y4 add with y5. Okay? And y4 you can write them in the term of y3, right? You propagate the data, okay, step by step. y4 equal to 3, y3. Okay, and y4, okay, in here. Okay, y3 is that, okay, you substitute screen part, yeah, okay. And the last one is, okay, y equal to y4 multiplied with y5. Okay, y4 is here. Okay, y5. Okay, y5 is, okay, the process form of the x. Okay. Now, this is a simple block diagram point of view or simple process point of view. A difficult, more complex process and the real application is the feedback control system. The feedback control system is very important system connections that is frequently used in automatic control. Yeah. The automatic control is with the control without the human being intervenes. Okay. The block diagram of the basic feedback control system is about here. Okay. You have the inputs, okay? Okay? You have measure them, the difference between the thing that you measure and the thing that you set. Okay, send them to the other, send them to the controller, and send them to the process. Right? Okay? Yeah, send them back to the system. Okay? The idea of them is, for example, okay, the example that I frequently give in this class is the air condition. Everyone knows about the air condition, right? I think today every home already have, or every condominium already have, right? Okay, when you go home, your room is very hot, right? Because in the day no one lives, right? You open the air condition, 25 or 23, right? Okay, we assume that to be 25. Okay, if the room temperature is 30, what happens? Okay, it is the thermosensor, right? Okay, it's measured 30 Celsius. Okay, the thing that you set is 25, right? 25. Is it different between them? Yes, 5 Celsius, right? 5 Celsius, okay, sent to the controller. The controller sends the signal to compressor, right? The compressor that works outside your room, very, okay? Some may be rowdy, some may be quiet, okay? Work that, okay? At the full speed. Okay, now, it generates, okay, it tries to reduce the room temperature, right? Okay, if it reduce, it can reduce suddenly. No, depend on your size of the air condition, right? It's some may be required 30 minutes, some may be required 15 minutes, right? Okay, for example, 5 minutes is already passed, okay? The room temperature is reduced to be 27 Celsius from 30, okay? It's cooler, right? But it's not meet your requirement, right? Okay, it's checking again. 27, 25, is meet each other? No, it's not equal, right? Okay, something different, 2 Celsius is different, okay? Send the signal to the controller still send the signal to the compressor, and you still working. Yeah? Until it's 25. If it's 25, what happened? The thing that you set and the real room temperature is equal, right? If it's equal, okay, no difference between them. Therefore, the controller will send the signal to the compressor that, hey, you can stop now for a while. That's why you see that if you can research about your compressor, okay? If your compressor is an old model, okay? It's not work the whole day, right? It may be work 30 minutes, stop 30 minutes. Why it stop? Okay, because it's already the room temperature is already meet your requirement, right? But if it stop, okay, what happened? The heat propagation from outside, right? It penetrates to your wall or to your room, right? Now, okay, 5 minutes is passed. Okay, stop. Okay, 5 minutes is passed. The room temperature is increased. For example, if it increased up to 26 Celsius, yeah, 26 Celsius, checking that, it's not equal, right? If it's not equal, one temperature is different, right? Now the controller is wake up. If it wake up, it send the signal to the compressor. Hey, wake up. Okay, this work. Okay, that's why this design is have two advantages. One, it can maintain the room temperature as it be, right? Maybe 1 or 2 Celsius, okay, varying from the thing that you set. The second, okay, instead you pay the cost very much, okay? The more compressor works, the more electrical charge. Okay? If the smartest model or the smartest air condition, it will be very quiet, okay? And the temperature precision is very high, right? Maybe 0.2 or 0.3 Celsius, okay? It's different from the old temperature, the room, the old air condition, right? The old air condition sometimes you set them to be medium or high. If you set them high, it's very cool. If you set them to be medium, it's very hot, right? For example, in the airbag in some room, right? Some room is very hot, but some room, for example, especially in the exam, is very cool, right? Not only you cool, the proctor is still cool too. It float together. Okay? Because, okay, this is the old model. Okay? If the smart model, I think some is very smart, right? It's already have the sensor, and the sensor can be upgraded easy. Okay? Now, this thing is not only used for the air conditioner. It's used for the upload process. Okay, for example, if you upgrade them, your generation, you can see that everyone know about the Tesla, right? The automobile can run by yourself. Yeah, use automation. Yeah, Your senior student is on, but the Tesla don't have the service in the Thailand, right? It has some problem too. Okay, the Tesla model is everything is based on the mobile phone or maybe by the key card, right? If the mobile, okay, it have one problem. If you park in the basement, if you have no mobile signal, how will you start the Tesla? You cannot, right? You must use your phone to push them until it's already outside the basement. Okay, therefore, almost all, when you see the Tesla in the Thailand, almost all, okay, by using maybe the key instead. Okay, but the key is different from the other key. Why? Everyone, I think the modern car already have the key frequency, right? And if it's broken, you go to the showroom key setting, right? To write about your frequency, or maybe go to some key fitting, okay, where it is. But the Tesla is not. The frequency that is set is not a single frequency in high band. It's modulation, it's encryption. Therefore, it's almost impossible to fit, except the Model 3. The Model 3 is allow you to download and fit your frequencies here from your key. For the other, it cannot. Except you can hack it. It's very fortunate that one of your senior students already have the ability to do that. Okay, because that some possible by the Tesla and use the key. It's not Model 3. Okay? Therefore, when the key is broken, you have only one way to do. You send the card, the key, to the US. It's almost impossible, right? Therefore, the car will be strong, okay, in the garage is maybe 6 or 7 months until your senior student, okay, is at the good time. There is called, he sent the email to some technicals that were fluent in the Tesla model, okay, so that some can encrypt it. Okay, encrypt that. You see that? The same. The automation is mean no human intervenes, but if it's broken, it's possibly difficult to fix it. Yeah. Okay. Now another one last thing. Okay, you can see that some of you used to hear about when you buy the air conditioner. Okay, you know about the inverter, right? What about the inverter? Why the inverter can save the energy? Very easy. Okay, you know that the engines today, the air conditioner will be not works the whole, right? It works and stop, work and stop, right? Whenever it starts, the compressor will be when the motor is start, it consumes the high current, and the high current is consumed, especially it's very high price for electrical charge during that time. Okay, the inverter try to maintain the speed of it. Okay, you see that when you listen, the air conditioner that have the inverters, the speed of them is not run full speed immediately. It's right to try to speed up a little bit. Yeah, this key is very important. Why? Because if it increase the speed from 0 to the maximum speed gradually, not suddenly. Yeah, the electrical current is that it consumes is not high. And the electrical charge is not high. But it has some problem due to it have electronics control. If your home is located in some electrical blackout figure, is it blackout, it's broken, or so on. The inverter have a high chance to broken too. And you know that the air conditioner with the inverter is usually expensive than the non-inverter, about 20%. If non-inverter is, for example, 20,000, with inverter maybe 25,000. And the one last thing, for the inverters, yes, it can save your money, but you must sure that it will operate about 6 to 8 hours every day. Therefore, it's suitable for your sleeping room. Okay. For example, in the dining room or the other that you maybe open or use them only 3 or 4 hours each day, it's not work. Okay. The sleeping, at least you must sleep 6 hours or to 8 hours, right? Some maybe up to 10. I don't know. Okay. Okay. Every day. Okay. You can. The private return is enough in the economic point of view. Okay. For example, means okay, I have install 2 air conditioners with the inverter at the sleeping room, okay. But for the ones dining room or the playing room, okay, I use the normal. Okay, because I don't open them the whole day, right? Maybe open them whole day only in the Saturday or Sunday, right? But the other is in the Friday. Oh, I teach you. No one use it, right? Okay. You are the engineering. If you must pay the cost, you must go on. Okay. And in this case, you can see that the key of the feedback control. You can see that the output, okay, depend on the input and the output itself. The key is here, right? The output. You can see that because we use some of the output perform as the input, right, to checking everything. Therefore, even though it's good to automate this, but you must consider them very, very careful because it has a chance to make the system unstable. How to make them unstable? The thing that made them unstable that you already know for many times. For example, when you open the microphone in the Microsoft Teams, why my voice is so loud? Because it will be feedback infinity, right? Okay, my voice in here, amplify that, right? Send them back in here, amplify it again until it infinity or it unbound. Okay, the microphone will be generate weird noise or something like that. Okay, that's why when you decide about the feedback control system, be careful. You must analyze about the stability point. Some case or usually case, the system may be unstable. Okay. For the general feedback control system case, the system output is mathematically expressed as the sum of the input and the output itself. You see that? Input and the output itself. Okay? Okay, for this, we will go for, wait a minute. Okay. Okay. Now, the last topic of this is the property of the system. Okay. What about the property? The property in this case is the mathematical property of the system. Okay. For example, the signal. How many property of the signal that we concern, that we analyze? 2. One is even and odd property. Another one is periodic, right? The signal is periodic or not. If it's periodic, you can apply Fourier series, Taylor series, power series. If it's a periodic, you must apply Fourier transform or the Laplace transform instead. See that? If you don't know about the system, it's periodic or aperiodic, you cannot use the suitable mathematics, right? For example, in the case that if the signal are periodic, if it's aperiodic, then you try to use the Fourier series. Even though you can integrate them, the final answer is still wrong, right? Because the first assumption that you try to apply them is well, it's wrong. Yeah. Now, the more you know about the property, the better you can analyze. Okay. These sections define the property of the property or the characteristic of this continuous time system. The properties definitions can be used to test the mathematically the continuous time system in order to determine this property. Okay, let xt to be the input and y is the output of the system. Okay, you can write them in this form. Okay, x generate y. Okay, this thing, the notation is called x produce y, and it can be represented as the following block diagram. Okay, the block diagram is here, right? Generate y. Okay, for example, the amplifier output depend on the inputs, right? You only amplify. Okay. Okay. Now, this section will present up to 6 properties of the system. Okay? Okay, we have the memory, okay, time invariant, invertibility, stability, and linearity. Yeah. The first one is the memory. The memory is mean if the system output at the time t naught or y t naught depend only on the system input value other than x t naught, then the system is memory. Otherwise, the system is called memoryless. Okay. What about that? The system in which is memory, we call them is called a dynamic system. But if the system is the memoryless, we call them a static system instead. Yeah. Now, in the mathematics, what about that? Okay. Yeah. If you consider that output, if the output at time t, depend only on input at that time t, the system is memoryless. Okay, it means we have no buffer in here. Yeah. For example, amplifier, your microphone, right? When I speak, it will generate immediately and it comes, right? The thing that I speak yesterday is not impact today, right? Yeah. Now the next one is here. This thing is called memory. Okay, if the output at time t depend only on input at that time. Okay. Next one. Yeah. 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 Output at time t, right? Still depend on input at time t, but you take square. Okay, okay, take square, therefore it still depend on the input at time t. It's still time, it's still memoryless. Yeah, it's still memoryless. Next one. Okay, yes. Okay, you can see that output at time t depend on the input at time t or not? No, it depends on the what about this front form? Time shifting, right? It depends on input, but it is shifting. Okay, it's not that time, right? For example, the thing that exists here not depend on the thing that you feed to that time. Maybe depend on the yesterday or depend on the tomorrow. Yeah. Therefore, this thing is memory. Memory. This thing is memory. Yeah. This is very easy, right? It's expressed in the simple mathematics. Okay, you can see them to be the memory or memoryless, very easy. Now, if it have a little bit complicated operator such as yeah, yt equal to what is operator? Integrate, right? You integrate from minus infinity. Okay, since the universe starts to t to now. Okay. Yt is memory or memoryless? Memory, right? It's memory. Okay, you might have the buffer in here, right? To process it. Therefore, the output depends on the input and its history. Okay. For the memory, we don't care. It may be depend on the history or it will depend on the tomorrow. Okay. Even though in the real physics world, it is possible that the current output depends on tomorrow, right? Because tomorrow is not exist yet. Okay, but in the mathematics it can. Okay, it can. Yeah. Now, clear? Whatever the memory is. Okay. Next one, the invertibility. The invertibility is if the distinct system input xt produce distinct system output yt, then the system is invertible. Yeah. For the invertible system, the system input xt can be determined uniquely from its system output yt. Okay. In order to make you understand, okay, I will show you. Yeah. Okay. If you have this mathematical operator, okay, the way to checking that the system is invert or not very easy. You can write n in the term of y here. You can write n in the term of y. If you can write them, the system is invert. Okay. For example, in this case, xt equal to yt by 5 or 0.2 yt, right? Yeah, clearly. Yeah. And if you change, okay, if you change the input, output is changing too, right? Yeah, yeah. Therefore, if yt is 10, xt is 2 unique. Yeah. Therefore, in this case, the system is invertible. Yeah. It means if you capture y, you can determine x clearly. Yeah. Now, for some case, yeah, some case is not. Okay. Yeah. Right. Xt equal to square root y, right? Plus or minus. Okay. Therefore, in this case, if you get y, if y equal to 4, what about the input is? Input equal to 2 or minus 2, right? You don't know what about the input is. Input may be 2 or input is minus 2, right? Therefore, you cannot reverse it. Okay? Because if you reverse them, okay, you cannot determine what about the exactly input is. Okay? Yeah. Okay? Therefore, in this case, the system is invertible. Not invertible, sorry. It's not invertible. Okay? The invertible system is very important in the engineering. Why? We frequently use them to model or improve the communication channel or the noise. Yeah? Anyone used to use the mobile phone? Okay, I will show you the next diagram first. Okay? The inverse system key is the second system that cascades with the system key and give the identity. The identity is mean 1. Okay? Yeah, 1. Okay? You can see that if you have this block key, if you have the inverse system, you cascade them to be 1, right? Out, it will be cancel the effect of the first block. Okay? Therefore, output equal to x, the original input is. Okay? You may have a question why we must create the inverse system. We frequently use them in the real communication channel. If you used to have a chat, you use the mobile phone 10 years before. Right? I think you can see your parent talk, right? 10 or 15 years before, it's almost impossible to talk in the dining room, right? You go to the very quiet in the garden or maybe in the toilet, right? To talk. Okay, why? Because a little bit noise in here, yeah? A little bit noise in here, your mobile phone cannot clean it, right? But today, even though you talk in the towers, in the market, you can talk that way, right? You can separate the noise so much, right? Because, okay, the signal in the mobile phone, okay, it will be measured about the background noise, okay, and separate it to model here. Okay, even though it's not separate all, it's not can eliminate noise all, okay, but it can separate a lot, right? That's why when you talk, okay, the human voice is already located in only some frequency range, okay, the noise is in the other range, okay, you separate it. If you separate them, you can listen to your voice easily. Yeah, that's one. When you improve, okay, the channel, this is only for your voice communication. That's why when you communicate in the wireless today, why the wireless technology today will be better than 10 or 15 years before? Because it can improve the noise in the channel. And it can make them send the signal faster than usually. 20 years or 20 years before, I think no one is there to upgrade your firmware with the wireless, right? Because you think that if it's broken, if it's stopped, your mobile phone is gone, right? But today, I think everyone upgrade the mobile phone by the wireless, right? Hey, the new firmware is come, okay, upgrade. Yeah, because the channel communication is so secure by here. Okay, you see that? Okay, the way to determine the inverse system is not easy. Okay, yeah, because the way to determine the inverse system, you must use about the Fourier transform, Laplace transform, or the set transform to find it. Yeah. Next one is the causality. Okay, the third property is, okay, if the system output at time t naught or y t naught depend on the system input value only for time less than t naught, then the system is a causal. What about the causal? The causal system is the non-anticipatory system or the real physics system. All physics system is a causal. Okay, the idea is of the causal is very simple. Okay. output depend on the input, the present output, the current output depend on the current input, and it is so. It is impossible to depend on the future, right? Because the future is not existing. Okay? If the system is belong to this, it means it's a causal. And all physics in the world is a causal, right? If, for example, in the microphone, even though you have the buffer, it can generate the echo or it can record my voice. It's still causal, right? It's possible that to capture my voice in the tomorrow or the future. It's impossible, right? Because today, if I am lucky, okay, if the rocket is flying here, I die. Tomorrow, it have no my voice anymore, right? Right? Or if the tomorrow is turn on this come, click, and I already to be dust. My voice disappear, right? Therefore, it's not make the sense that the current output depend on the future. It must depend on current input and maybe depend on the history. Yeah. So guys, yeah, this is the system. Okay, output depend only on the input at the time, right? It's a causal, right? It's memory or memoryless? It's still memoryless too, right? It's still memoryless. Okay. The system, okay, the output depend only on input at the time. Okay. Yeah. Yeah. Output depend on the input in the history. Causal or not? Causal, right? Causal. Okay, causal is mean it can depend on the current and the past. Okay. Memory or memoryless? Is memory, right? It's memory. Yeah. Yeah. Okay. Output depend on the future of the input. Causal or not? Non-causal. Memory or not? Memory is mean output depend on that time. YT depend on memory XT. Therefore, is memory. Also, memory. I think it's all that. I little bit confused. Okay, it's not memory. Okay, it's memory. It's memory. Sorry. Okay, the last one. Okay, non-causality, and the last one is here. Integrate from to T to now. Therefore, output depend on the input from -infinity to now. Causal or not? Yes. Causal, right? Memory or memoryless? Memory, right? Yeah. You can see that why you must concern about the causal. When you create the system, sometimes the system that you create in the mathematics is non-causal. If it's non-causal, it means is it possible to build in the real world? No, right? If you can tell me, okay, I will guess that, okay, I can predict about the next time locally. Right? Because it's impossible, okay? Okay. Now, the next one of the main topic of the system analysis is the stability. If the system is unstable, it is useless to operate, okay? Okay? If the system output YT remain bound for any bound system input XT, then the system is the BIBO stable or the bound input and the bound output stable. In fact, the stability has so many definitions, but in this case, we specific only on BIBO. What about the BIBO? BIBO is mean, BIBO stable is mean, if the input is stable, it's not infinity. You don't feed infinity signal to the system, okay? You feed a finite value, okay? The output must stable. Yeah, if the output is it's okay. It's BIBO stable. Yeah. Therefore, you check it first. If the XT is bound, what about is bound? You can check the minimum and the maximum of them. Okay. If the input signal have the maximum value and the minimum, even though the maximum is maybe 1 million, 10 million, or so on. But if it's not infinity, yeah, if it's less than infinity, it means the input is bound. Okay, if the input is far, for example, you measure the signal. Okay, the input signal is have some point that is reached to very peak, very high. Okay, but it's still finite. If m is finite, okay, you checking that for the output. If the output is have some not infinity yet, okay, it's mean, okay, the system is stable. Okay, how to checking that? I will show you the example. Okay, if the system is here. Okay, y equal to x squared. Okay, memory or memoryless? Memoryless. Causal or non-causal? Causal, right? Okay, now we're checking that. Okay, stable or not? Okay, if it's stable, okay, it means if the input is finite, it's less than m. M is mean some criteria. Okay, some maximum value. Okay, if the input is less than m. Okay, equal to m at the maximum. Output equal to, what about the maximum of the output is? Output equal to m squared, right? If m stable, m squared is stable or not? Stable, right? Therefore, the system is called, okay, the output will be less than m squared. If m is finite, m squared is finite, the system is stable. Okay, now, we show you in another case. Yeah? Yeah, integration. Yeah, integrate from infinity to none. Yeah. Now in this case, you can see that if the input is ut, what happens? Input is ut, right? Ut. Yeah. Input is ut. You integrate from infinity to infinity. Yeah. Integrate all to very high one. Therefore, when you integrate them, the more you when the t is increased, this increase to right and leads to infinity soon, right? Therefore, in this case, when you integrate them, you substitute them in here, integrate ut, okay? T ut give you here, give you infinity. Okay? Or for example, in another simple example is here, if yt equal to 1 divided by x, seems very easy, right? I would like to ask that if x equal to 0, 0 is bound or not? Is finite or not? 0. Infinity or not? 0? Not, right? Have some value, right? When you substitute in here, give you infinity, right? Therefore, in some point, the system may be unstable. Okay? You may have the questions why you are concerned about that. Because if the system is unstable, it's your main job to make them stable. Sometimes you may, why is it unstable? Build a new one. The factory already built for a long time and it's very maybe 1 million or 10 millions, right? Done. You can erase all to build a new one? No. You can build some block, right? To make them stable. It's a key that you study in the next subject, the feedback control. Okay, if the system is unstable, how to make them stable. Okay, how to fix the problem. Okay. Another two topic. Okay, now, okay, for the time invariant. Okay, for the time invariant is okay, the time invariant. Okay, the system. If the system input xt, that is the time shifting, produce the system output yt. That is the same time shifting. Then the system is called the time invariant. Yeah. Okay, if you already have the class, you will code it. Okay, forward. Maybe only 2 minutes we finish about that. Okay, don't worry about it. Okay. I know that about the each subject is very serious about your attendance. Okay. Okay. For the times, okay, time invariant. The time invariant is very easy. Okay. It said that the system is called time invariant if you process them and you ship them. Okay, if you here, or you will ship them first and process them later. Yeah. If it equal in the mathematics, okay, you can conclude that the system is time invariant. Okay, for the time invariant. For example here, okay. Now it said y equal to exponential xt. Okay, if the process is exponential acting. You process them first, okay? Process them, okay, y equal to exponential x, right? And you shifting them. Shift every t by t naught, right? Shift every t by t naught. Okay? Now you check that if you shift them first. If you shift them first. Okay? Shift them first. Delay them. Okay, shift them first. And process it. Okay? You process, okay, x t minus t naught is given here, right? This is equal. Right? If equal is mean the system is time invariant. Okay? But if it not, okay, if it not, for example here, what about this transform? Time reversal. Okay, if your main process is the time reversal, we check that the time reversal is the time invariant or not. Okay? You will process them first, check it, reverse it, right? And you shifting them, shift every t bar, okay, t naught is same, right? Now, if you shift them first, okay, if you shift them first, okay, yeah, right, and process them. When you process them reversal, you reverse for all, right? Reverse for all, it give you here, right? Minus and minus, right? Identical or not? No. No, it's mean it's time invariant, right? That's why the process for compute the time transform, okay, shift first or reverse first is very important, right? The final answer is different. Yeah? Yeah? Yeah. Now, this thing used to check so many things, okay? For example, it's some of the simple example that I frequently give it to you, okay? What about your girl? Anyone need to have a girlfriend? Or boyfriend? Girlfriend? Your girlfriend is that time invariant or not? You can check that, okay? Very easy, okay? You set the date first, okay? Okay? You go, hey, tomorrow. You go to the day, go to the theater, okay? Now, you plan to delay 6 hours. Okay? Process. If you go in time, 9 o'clock. 9 o'clock, okay? Okay? You take the, go to the theater, okay? And you can walk a little bit long, 6 hours with her, okay? To see anything, eat anything, okay? She's still okay, right? But if you let them first, what happens? You send them 9 o'clock, but you go to about 3 p.m. I think she is moody, right? Or upset, right? Even though go to the theater, but this feeling is still maybe better but not good, right? Equal or not? No. Therefore, the girl is time invariant. Vary from time to time, right? Just kidding, okay? Yeah? The last one is linearity. Yeah? The linearity is if the system satisfies the principle of superposition, additivity, and the homogeneity, then the system is called linear. Yeah? What about the linear? The system satisfies the principle of the superposition if the inputs and the output can be defined by here. Yeah? Yeah. The system is a linear. Okay, if you feed x1, it generates y1. Yeah. If I feed x2, it generates y2. Yeah. Now, I would like to ask you, if I feed x1 plus x2, what about the output is? Yes. If the output should equal to y1 plus y2, right? If it equal to y1 plus y2, it means the system is linear. Yeah. Yeah. The system is linear. Yeah. Even though you multiply with the constant a1 and a2, it's only constant. Yeah. The key is x1 plus x2 equal to y1 plus y2. Now we can check that. Okay. For example, here in the real case, yeah, a system is a simple amplifier. You amplify by what are we transform? Amplitude, right? Like the amplifier, you amplify by 3. Okay. Now if you fit x1, okay, x1, I would equal to y1 equal to 3x1, right? Okay. x2 equal to 3, y2 equal to. Okay, now when you fix x1 plus x2, okay, now checking that, okay, x1 is x2, okay, give you, okay, yeah, right? The real system is amplified by 3, right? Real system is multiply all, right? 3 multiply all. Okay? After you multiply them, try to reorganize them in terms of y1 and y2. Okay? Okay, you check that. Okay? This 3x1. 3x1 is y1. 3x2 is y2, right? You can write them. Okay, therefore, you can see that, okay, x1 plus x2 equal to y1 plus y2, right? In this case, linear or not? Linear, right? Linear. But in some case, it's not. Okay, for example, x squared. X squared, okay? You feed x1, give you x1 squared, right? You feed x2, give you x2 squared. But if you feed x1 plus x2, okay? If you feed x1 plus x2, it gives you x1 plus x2 squared. If it is 1 plus x2 squared, you distribute it, right? It gives you x1 squared, x2 squared, and this is 2x1, okay? In the book, it's already correct, but in the slide, it's not, okay? Yeah, this therefore, x1 squared gives you y1, right? x2 squared gives you y2, but what about this term? The term here is not, right? Therefore, it's not equal. If it's not equal, it means non-linear. Yes, non-linear. Yeah, see that? Now, you can check that your girlfriend. Okay. Now, you can see in both file view. Okay. First time, you do something wrong with her. You have the first key. First x, okay? First girls, okay? And if she fine, what happened? So angry, right? Yeah. If okay, if she forgot it, it's okay, right? If you do it again. Yeah. The same situation? No. Maybe double or triple, right? Accumulate from the first case, right? Therefore, the final answer, okay, the thing that you do wrong is the correct. The second is not the same, right? And both is different. The result is very big, right? Serious, right? Therefore, the third is not linear. You see that? You see that, okay? Because don't worry about that, okay? Not only the girl, the man, the human is the animal. The mind of the animal is always non-linear. Yeah. For example, okay, if you do something good with her, for example, you buy the diamond to her. The first time is oh, very impressed, right? The second time you buy, not impressed like the first one, right? Diamond again. You see that the same thing, it is different. If you buy 2 diamond again, right? Different. You see that? If you do something wrong, it amplifies wrong. You do something good, the same manner, but why? It's not incredible like she angry. Yeah? I don't know because I'm not a philosopher. Okay? I'm engineering. Okay? You can see that, you can check that. But when you check, don't tell them, my instructor told me to check you are time ignorant or not, okay? She will kill me, okay? Now, let's see, okay? One last thing. Okay? The one last thing, okay? Your exercise. Okay? 30, 31, and 32. Okay? Checking that the system is linear or not. You will see that I don't give you too much, right? Okay? In fact, you have so many problems you don't do it yet, okay? But I order you to do only the minimum. But if you would like to get a good grade, I recommend you to do all, okay? Only here in the exercise, not from the outside of the book, okay? Yeah? See you next time.
Thursday is holiday. Thursday.
Yes, holiday. In fact, it's no holiday, right? No class. Yeah. For me, if you would like to study by Microsoft Teams, I can open in my house. But I don't think so. You maybe would like to take a vacation, okay? See you again. Don't forget to take the exercise. I don't give you so much, okay? Try to do them, and I will give you a solution to fulfill. Okay? Good luck. ครับขี้เกียจ